Hello everyone, this is Mr. Fugay, and for this video today we're going to talk about special right triangles. This lesson is actually a two-part lesson, so today we are only going to cover part one. There are two specific types of triangles, right triangles that we're going to be discussing. So today we're going to discuss what's called the 45-45-90 triangle. But before we get into that and how we can solve some problems with that, there is one vocabulary term I want to make sure that we have a chance to address, and that is the term opposite side of a triangle. And so that definition is here. So it's the side of a triangle that is across from the angle. It is the side that doesn't touch the angle. We're going to use this term opposite side of an angle very often throughout the next couple units. So I wanted to take a moment in this video to make sure we understood what that meant. So let's take an example, this right triangle here, that is triangle ABC. Sure, I guess I could be more creative and give it a different name, but maybe we'll call the other sides G, the side lengths that are E, and we'll call this alongside O. So the idea here behind the opposite side is that if I am now referring to what is the opposite side of angle A, what I'm basically asking you to do, and I'll use the green here, is to look for the angle that is across or not touching that angle. So in this case, this would be E would be considered the opposite side. So we're going to be using this terminology a lot, so that's why this is important here. For angle B, we go across and we look across. You see that this opposite side, so for angle B, the opposite side is going to be G. So G is the opposite side. And last but not least, we have angle C here. When we look across, it's actually going to be its hypotenuse. So one thing I will say often is a right triangle's hypotenuse is opposite from its right angle. So there it is, opposite side there. So keep that term in mind because we're going to be using it every once in a while throughout this lesson and our next couple lessons after this. So scrolling down, I would like you to look at these 5 triangles, okay? All of these 5 triangles have something very unique in common. In all of them, you'll notice that 2 of the side lengths are the same. So in the case of the first one, we have those marked here. The 2's are the same, the 3's are the same, 4 and 5. And so that makes these, by definition, an isosceles triangle. Since the angle is 90 degrees, that means the other 2 non-right angles would have to be equal to each other since this triangle is isosceles. So 180 minus 90 is 90 degrees. And the other 2 angles then would have to be equal, therefore making them 45 degrees. So this lesson is going to be discussing these 45, 45, 90 triangles, as I'm going to be calling them. And so what they have in common is they are all isosceles right triangles, as I mentioned. They are similar by angle. So that idea that they are similar is going to be important here, since the corresponding angles, as we said, are 45, 45, and 90 degrees. So looking at these triangles below, I'd like you to take a moment to pause this video and use the Pythagorean theorem to try and find the missing third side. And the key here that I want you to do is to make sure that your final answers are in radical form. I will add one other thing. If you get 2 or 3 into it and you start noticing a pattern, remember that these triangles are similar. So don't be afraid to use a pattern if you need to. So pause this video and try to solve these problems below. Did you guys notice a pattern? Hopefully you found one. In the first one, it's 1 squared plus 1 squared equals x squared. That means 2 equals x squared, therefore x is equal to the square root of 2. Now in our next question, we ended up getting 4 plus 4 equals x squared, so therefore the answer here is square root of 8. But the key here is we got to break that down and simplify it, because square root of 8 is actually 4 times 2, square root of 4 times square root of 2, therefore the hypotenuse was 2 root 2. In the next one, we had 3 squared, which is 9, 3 squared, which is 9, and then the x squared. This time we're simplifying the square root of 18. When you simplify the square root of 18, we get 3 root 2. So take a notice here of what you're seeing here. So in the next problem, if you didn't notice it, you would have gotten the square root of 32, I believe. And when you simplify that one, you get 4 root 2. And I'm hoping now by this point you'll notice that whatever the leg is of an isosceles right triangle, its hypotenuse is just going to be that number times the square root of 2. So this is no coincidence because, as I said, these triangles are similar by angle, which means their ratios are the same. So we're going to specifically talk about these ratios of the 45, 45, 90 triangle, also known as the isosceles right triangle. And here it is below. So in a special right triangle that is a 45, 45, 90 triangle, we have our three sides. The longest side is going to be considered our hypotenuse. And the other two sides, we're going to call them our legs. So we'll call them our legs. Now, in the case of this here, if we want to generalize the rule, the idea is that if you know what the two legs are, they have to be the same since the triangle is isosceles. Let's go ahead and call them x and x. Therefore, if you want to figure out what the hypotenuse is, all you would do is take the value of x, the leg, and multiply it by the square root of 2. So these ratios, right here, here, and here, are what we're going to use to compare with any other 45, 45, 90 triangle below. One thing you might notice here is 45 degrees, its opposite side is x. 45 degrees, its opposite side is x. And then the 90 degrees, its opposite side is x square root of 2. So I have those angles and side ratios here off to the side. We're going to want to use those as we move through to solve for missing parts of a triangle. So let's go ahead and go look through 3 examples. Here's our first one. It's asking us to find the length of the missing side. So the best way we're going to do this is I have a 3-step process for this, and it's the easiest way for us to be able to do this. First is we want to label the sides with their opposite angles. So in this case, we're going to take the 45 degrees, and we know that the opposite side of the 45 degrees, as noted on our diagram here, is equal to x. This 45 degrees is also equal to x. And then our 90-degree side, which is the hypotenuse in this case, is x root 2. So what we're going to essentially do is we're going to look at, well, I know this is 10, and I know that this side is x. So what I'm going to do is I'm going to set those two things equal to each other. And so in this case, pretty straightforward here, we already know what the x value is. The x is equal to 10. So when I'm labeling my 3 sides, one way I like to do this is we'll call it x, x, and x root 2, meaning those are the 3 sides that are similar to the triangle that we have above. Since we know x is equal to 10, the first side would be 10. Well, that one was given to us. The second side is also 10. And then this side, the x root 2, we're going to substitute the x in, and we're going to get x root 2. So this is a pretty straightforward question, and of the ones that we're going to go over, this is definitely going to be the easiest question, the easiest type of question that we're going to look at. Let's look at example number 2. So in this case, in this situation, we have now been given the hypotenuse. So let's go ahead and label our sides. So our legs are going to be x, and our hypotenuse is going to be x root 2. Now you'll notice in this situation now, we actually don't know what x is equal to. What I do know is that if I'm comparing this to the ratios that I do know, that 4 is equal to x square root of 2. So if 4 is equal to x square root of 2, we can actually solve this for x, trying to help us find out what the x value is. In this case, I'm going to get 4 over the square root of 2. Now, if you know from a previous lesson, we've talked about this idea that if you have a square root in the denominator, we want to be able to rationalize that denominator. And the trick from that is we multiply top and bottom by square root of 2. So when I simplify this, we're going to get 4 root 2 over 2. Thankfully, in this case, we're not going to have to keep a fraction here because 4 and 2 go into 2. So the value of x here is going to be 2 root 2. So looking at our diagram here, we know that the side that is marked x, the side that is marked x, and the side that is marked x root 2, we now have all of our answers. We know the x root 2 side was equal to 4. We now know the x side, since we solved for x, is just 2 root 2. And there are my 3 sides for example 2. So keep an eye here of our steps, right? We labeled our sides first. I did that in red. The second thing is you solve for x. So you set whatever side you know equal to its corresponding label. And then once you find out what x is, substitute it back into all 3 sides to find the lengths of this triangle. Let's take a look at one final example. And here it is below, example 3. I'll finish that square root symbol there. In this situation, again, if we remember the opposite sides of 45 degrees, if we measure them, are going to be x. Opposite side of 45 is x. opposite side of 90 is x root 2. So first thing I'm going to do is identify my pair here and know that, okay, in this case, x is indeed equal to 5 root 2. So now it's time for me to label the three sides of my triangle. We have the x side, and then the x root 2 side. So in the cases of the x sides, that's going to be pretty easy. It's 5 root 2 and 5 root 2. But what makes the hypotenuse one unique this time is that I'm going to substitute what my x is, okay? And I'm still going to have to write root 2 after it because that's part of the ratio relationship. In this case, the value of x we found was 5 root 2. So we have 5 root 2 times root 2. And so in order to do this, we're going to have to multiply these square root of 2's together. Square root of 2 times square root of 2 is indeed the square root of 4. But remember that that is actually equal to 2. So my answer here for the hypotenuse, 5 times 2, or 10. So the three sides of my triangle, the two legs are 5 root 2 and 5 root 2. And in this case, my hypotenuse is going to be 10. So ultimately in this video, as we wrap up this lesson, the big thing you want to make sure to keep an eye on is we want to label our triangle with these ratios, x, and x root 2, based on this pattern that we noticed that all 45, 45, 90 triangles have in common. So after looking at these, you might see some shortcuts and some other ways that you might be able to find these. I find the easiest way is to label the sides opposite the angles, then solving for x second, and then substituting when appropriate. So those are the examples. I'm going to give you an opportunity now to try out some problems. Down below, you'll see there are 4 examples on the U-Try. I will have a second video that will go over these questions in detail and look to that if need be. Besides that, that's everything for this lesson. Hope you guys enjoyed it and have an awesome rest of your day.